problem set here. They've given us this graph. The line we're starting with is this guy here, the lower one, and we're calling this one f of x. Okay, so there is f of x. They ask us consider the graph of f shown in blue, which is the one I've tried to bold here. Find a possible formula for the transformation f shown in the same coordinate system in red. So essentially, we're taking this guy and we're going to find some sort of transformation that's going to put him on top of this other function that they have shown us here. So the first thing you need to look at is look at the amplitude. So basically, this bold one, or blue one per se, goes from -1 down here up to +1, right? So it's got an amplitude that goes from -1 to 1, which is 2. All right. Now compared to the big one goes from 3 to -1, which means it's going to span a distance of 4. So that's going to be 2 times as big. So 2 times as big means it's going to be 2 times f of x, right? Because the amplitude, the up and down, relates to the y, which is on the outside of the function. If it were to be twice as big, we'd multiply the 2 inside here, but we're doing the y, so we're multiplying the outside. Does that make sense? Alright, and then our problem is they both have the same bottoms right here. So if we were to just leave it as this, it would overlap and kind of look like this. But it doesn't look like that, right? So what we have to do is we've got to shift it up. And if we look at just one point, so say we look at the point here, we know if we multiply it by 2, it would have a point there. That point needs to be up here. So what we do is we shift it up by 1. So basically it's going to be 2 f of x plus 1. And that'll get this multiplied by 2 gets bigger, and shift it up 1, it's going to drop it right on top of where we want it to end, right there in the big one. Alright, so your answer is 2 f of x plus 1.